intelligence. Today, we are exploring India's first orbital data center satellite. The story begins with Pixxel, a Bangalore-based imaging satellite company partnering with SarvamAI to launch Pathfinder, a 200-kilogram satellite carrying data center class GPUs alongside Pixxel's hyperspectral imaging camera. Scheduled for orbit by late 2026, Pathfinder is designed to test whether ground-grade hardware can survive the harsh environment of low Earth orbit. So what exactly is an orbital data center? Imagine a constellation of satellites equipped with GPUs capable of training and running AI models directly in space. Instead of relaying raw data to Earth, these satellites process information in orbit and beam down only the conclusions. It's edge computing, but extended to the cosmos. Why are global firms suddenly interested? Three forces have converged. First, terrestrial data centers face limits on energy, land, water, and regulation, all amplified by AI's growing demands. Second, in orbit, solar power is nearly continuous, offering free electricity. Third, competitive positioning. Companies like SpaceX, Amazon's Blue Origin, Microsoft Azure Space, and Lone Star Data Holdings are racing to prove orbital compute is viable. But challenges remain. GPUs powered by solar panels get hot, and in space, there's no air to carry heat away. The only solution is radiation. Heat is pumped through ammonia-filled loops to deployable panels, which glow in infrared and dump waste energy into the vacuum. This passive cooling eliminates the massive expenses of air conditioning and water towers on Earth. Over time, the absence of cooling and grid power costs could offset the high capital outlay of launch. Radiation damage is another hurdle. Cosmic rays cause bit flips and degrade semiconductors. Radiation-hardened chips lag behind commercial GPUs, and maintenance in orbit is nearly impossible without robotic servicing. Redundancy must be built in from the start. So what does the Pixxel-Sarvam partnership involve? Pixxel will design, build, launch, and operate Pathfinder, while Sarvam provides the AI backbone, running full-stack language models on GPU layer. Their hyperspectral camera adds immediate utility. Image captured in orbit can be analyzed in orbit with only the insights transmitted to Earth. A single satellite is more expensive than the same hardware on Earth, but there are other costs in terrestrial cooling which is higher to be argued. Cooling costs disappear in orbit. On Earth, data centers spend huge amounts of money on HVAC systems to remove heat from servers. In orbit, it's dumped through radiation. Radiators don't consume extra energy like chillers or fans do. Terrestrial cooling often requires water for evaporative cooling towers. In orbit, there's no water infrastructure at all, so that expense vanishes. Grid power costs disappear. Satellites in the right orbit receive nearly constant sunlight. Solar panels provide free electricity, unlike Earth data centers that pay for grid power. There is no rent, no electricity tariffs, and no dependency on regional grids. Once launched, the system is self-sustaining. There is a trade-off. Launching satellites and building radiation-hardened GPU systems is far more expensive than building a terrestrial data center. Pixxel argues launch costs will be reduced when SpaceX Starship is operational, and the elimination of cooling and grid expenses parity could arrive in 5 to 10 years. India's Pathfinder is a demonstrator, but it marks the beginning of a new frontier, a future where computing isn't bound by Earth limitations, but expanded by the infinite possibilities of space.